Okay, we're going to look at some problems with Pythagoras. So we've looked at some basic Pythagoras where you calculate the length of the longer or shorter side. But we're just going to put it in more difficult context now, so let's try this one. Okay, so to sketch this diagram. Okay, so we want to imagine that this is some kind of tunnel that trains would go through. Okay, so it's basically a circle with a bit of the circle chopped off the bottom. Okay, now what we're told is that this length here is 10 centimetres, and we're told that this length here is 18 centimetres. Okay, now the question is asking us to find the height of this tunnel. Okay, now what we're going to do is use a bit of Pythagoras to do it. Now if we're going to use Pythagoras, that means we need to look for a right angled triangle. So we're trying to create a right angled triangle in the question. So let's get that one there. Okay. Now, when I put that dotted line down from there to there, that creates a right angled triangle. Now what you can also see is that's taking that 18 and halved it down the middle, so that bit there would be 9 centimetres. Okay. Now what I can do now is I can find this side here, so I'm going to call that side x. Now you can see that that's one of the shorter sides, so if it's a shorter side that means I subtract. So it's going to be x squared equals 10 squared minus 9 squared, and that's x squared equals 100 minus 81, and that's x squared equals 19, and then take the square root, so the square root of 19, and then round that to one decimal place, and that will give me 4.4. Okay, so 4.4 centimetres. Okay, now the next thing is I need to try and find the height, so I know that this bit here is 4.4. Now if you think of it, this is a circle and the bottom of the circle has been chopped off. We can see that this bit here is the radius 10 centimetres, and that means no matter where I go across the circle, that radius is always 10 centimetres, as I'm indicating here. So that means that this bit here is 10 centimetres. What I've worked out is that the bit x is 4.4 centimetres. So to find the full height then, I would need to do 10 plus 4.4. And that will give me a final answer, which is 14.4 centimetres. Okay, let's just talk to this one from the start. Okay, first thing, as I was given the shape just with 10 centimetres here and told that this was 18 centimetres, I then created a right angle triangle here and I halved this 18 down the middle. Now when I've done so, that means that this bit was 9. I've then got the hypotenuse and I've got 9, so I'm going to find that side, call it x, and I'm going to subtract because it's one of the shorter sides. X squared equals 10 squared minus 9 squared, that gave me 4.4. So that told me that this bit here, x, was 4.4. I then could see that the radius all the way around the thing was 10 centimetres. So that bit's 10 centimetres. And then I add on the 4.4 will give me 14.4 centimetres for the height final answer. Let's try an example 2. Okay, that's example 2. Okay, first thing I need to do is try and create a right angle triangle, so I'm going to get it by slicing down here. So let's do that. So that then halves that 12, and that means that this bit here will half a 12. That tells me that bit's 6 centimetres. I'm going to call this just a random letter, I'll call it x. And then I can do Pythagoras again. It's one of the shorter sides I'm finding, so it's going to be subtract again. So it's going to be x squared equals 8 squared minus 6 squared. So that's going to be 64 minus 36. So that's x squared is equal to 28. It's then x equals the square root of 28 into one decimal place. That will give me 5.3. Okay. The next thing is that I know if that's 8 centimetres, that's 8 centimetres, that's 8 centimetres. That bit there will also be 8 centimetres. I know that x is 5.3, and I know that that bit there is 8, so you get the full height. I just add them two together, and that's h equals 8 plus 5.3, which will give me 13.3 centimetres. Final answer. Okay, let's try one more. Okay, there's the centre. Right, I'm told that that bit is 9.5 centimetres, and I'm told that this bit here is 16 centimetres, and the question is asking me to find the height of the shape. Okay, look for a right angle triangle, so if I cut down there, that will give me the right angle triangle. Now what that does there is that splits the 16 right in the middle, which means this bit here, same as last time, half it down the middle, that's it. I'm going to call this side something, you can call it x, t, q, whatever. Now I've been given the hypotenuse, so that must be one of the shorter sides, so it's x squared equals 9.5 squared minus 8 squared. Okay, so use your calculator with that one, and that will be x squared equals 26.25, don't round at this point. Next move, take the square root of 26.25 into one decimal place. I can now round that, and that will give me 5.1 centimetres. Okay, so I know that this bit here is 5.1 centimetres. I know that the radius, so the radius is from the centre to the outer edge, is always going to be 9.5, so no matter where I go around the circle, around that bit of the circle, it's going to be 9.5, so that means that this bit is also 9.5. So the height is going to be the 9.5 plus the x bit, which we've just found to be 5.1. So add them together then, 9.5 plus 5.1 will give me 14.6 centimetres. Okay, so there's 3 examples. Do the exact same thing again, get your right angle triangle to get going, split this down the middle, that'll be 6, find this length, and then get that length, which should be easy, add them both together, and that's the same, and we'll pick that up tomorrow. Remember also to do the daily homework on expansion of brackets. We'll pick that up tomorrow as well.